I'm going to talk. First of all, something about the principles of caching, because Bcache is a caching solution. A brief overview about the available caching solutions, so you can evaluate what I'm talking about. Then a bit into the theory of Bcache, how it can be used. Then some actual numbers, my conclusions about it, an overview about what is left to be done, and time permitting, an actual demonstration. Okay, so SSDs are cool. They are unfortunately also quite expensive and small. The small part could be rectified by employing many of them, but that would make the expensive part even harder. So we would like to have something that is as large as a normal rotational disk and as fast as an SSD. To understand the problem involved in that, it's necessary to look a bit at the meaning of fast. SSDs are fast, yes, but there are two meanings of fast. Either you can have throughput or you can have latency. And it turns out that while SSDs are quite good at throughput, they're not great. They're just good. In terms, still works. Anyway, in terms of latency, they are practically unbeatable. RAM is better, but RAM has the problem with power. So, the terms of throughput are important because sometimes your caching solution is not up just against one disk, but against a RAID array. So the challenge in a caching solution is to have something that combines the speed in latency of an SSD and does not take too much of a penalty for the administrative overhead to worsen throughput. So, what's available? Status of a few months ago. We have enhanced I/O, which is derived from flash cache, which was the first solution written by Facebook. Enhanced I/O is rewritten and now is read-write instead of read-only. And when it was still read-only, it generated, as is often the case, a rival project called Bcache. The main difference here is the administrative structure. Flash cache used and enhanced I/O still uses administration of the cache in RAM by means of a hash array, and Bcache uses B trees, hence the name. There is also Mcache built on the device mapper infrastructure. The other two solutions are not. I won't consider it, and I haven't, as long as it doesn't do safe writes. Bcache, an enhanced I/O write that is reported as written, has hit the disk. The Mcache cannot make that promise, and as long as it does not do that, I'm not going to use it. And the user space tools are reported to be terrible. Anyway, how does Bcache work? It operates on block devices. That means that what you use as a cache, in theory, does not have to be an SSD. You could use a rotational disk to cache an old CD. I'm not commenting on making sense of that, but it would work. It has the other limitation, on the other hand, that it needs a backing block device. So using it to cache NFS, no way. Same for the other network block devices. And just last week, somebody came up with the idea of using TMPFS as a cache device. Won't work either. There need to be block devices. It has currently, not in the design, the limitation that you can't use it for a clustered file system. And as far as I know, it has never been tested on a changeable medium. Well, it should be done. This is not funny, because changeable media are among the slowest, but it needs additional logic. The code as it is now works. I've not found a crash or any data corruption, but it is not extremely mature. So, on disk, imagine you have your disk, then you have partitions on it, I hope, and on your SSD likewise. I've made a nice graphic to show that. So on your left, you have the backing store partitions, and on the right, the SSD partitions for caching. I'm assuming here that the backing stores are actual rotational disks, so they're round. And the SSD are sort of rectangular. Anyway, so on your backing store and on your cache, you generate a special super block for Bcache, and secondary to that super block, you create the file system's actual super block on the backing store. So from your point, the cached partition is no longer a normal file system. The block ID tools will show it as a Bcache partition. Actually, they should. They didn't on factory. I fixed that. Well, I've made a patch. It's not yet submitted. This is the point here, that you cannot accidentally mount something that is dirty, which is good. And the problem is you cannot mount it in any other format than as a Bcache device, which means if your Bcache tools or the Bcache module don't work for some reason, your data is not lost, but it is inaccessible. Currently, in contrast to RAID, there is no auto-detection of Bcache devices in the kernel. So you could set it up from an init RD before the root file system is mounted. Then you can cache your root file system, in theory. I haven't looked into that, and I frankly think it is a bit silly, because on a modern SSD, you'd have at least 32 gigabytes, which will take up any reasonably sized root file system. If you're putting some special thing on it, you can use a partition for that and Bcache that. In my opinion, it just makes no sense to put your root file system on Bcache, but in theory, it should work. So the caching solution has one principal problem in any design. What is your cache and what is your backing store? And if you have several caches, which is which backing store's cache, and vice versa. Bcache does that by unique IDs. You set them up at the beginning, and the kernel, as you register your devices, reads the IDs and compares them, and then automatically assembles the cache device. That means that you can reassign this on the fly, and you have as much flexibility as is, in my opinion, possible, barring some bugs I discovered today. But if you have to type in such a unique ID yourself, no fun. The system is set up so that for administrative purposes, you can use a clean backing store without a cache. You need that during migration from one cache to another. And one cache device can serve essentially, other than by integer limit, number of backing stores. I haven't tested that, but in theory, good idea. In practice, I doubt you'd use it, but we will see in the future. So, the whole thing is administered by sysfs. You just register via a special file in the Bcache directory your devices, and they are recognized by their unique IDs, so you just write them in and everything will work. There is a tool set which generates the secondary superblocks and does a bit of administration. This works well. For anything more advanced and reading out the statistics, you can and must, unfortunately, directly access the sysfs, but the statistics are easy to understand and there is not that much to be seen there. The system is administered by sysfs, but anything you change there is indeed persistently stored on the caching device. You can change the caching modi, of which Bcache has 3, and those are important, so I'll have to say something about them. There is in every caching solution the problem of what to cache and when to cache it. The usual and probably only solution in that case is that you cache what you read and at some point evict it. But when reading, there is a problem. As I told you, SSDs have great latency, but not so great throughput. It is still larger than any conventional disks, but to cache, you have to read from the conventional disk and write to the SSD. That can be done, but it is obviously slower than just reading from the conventional medium. So there is a chance that you actually worsen your performance. And this would happen if you were to cache large sequential reads. For that reason, Bcache does not do that. And there is the problem that your caching device is necessarily smaller than your backing store, otherwise there is no point in using a cache. So you cannot cache everything but the valuable stuff. So there is a hard limit in Bcache for what to cache. There is an option to do a read ahead. I've tested it a bit. I found no significant benefit here, but it may be beneficial on some configuration. I can't really tell you. So, the caching modi are material to writing to the disk. You would ideally also cache what you write on the suspicion that you will reuse it. So there are 3 logical combinations if you have 2 devices. You can either write it to disk and not cache. That has the very obvious benefit that you do not have the cost of the second write. Because at some point you will have to hit the disk, so why not do it just at once? You can write to both. Obvious problem, it is slower. Because you need to write at least twice, in practice more, because the administrative data is on the SSD, so it can turn into, well, if you're unlucky enough, you have to rebalance the B tree, and that is costly. In practice, this is again mitigated by the limit for large consecutive reads and writes. But if you switch that off, which you can, yes, there is the case that Bcache actually slows things down. And there is the most cool setting that is write back. you write only to SSD and do the writing to the actual disk in the background later, which means you, in principle, should get, minus the administrative overhead, the full seek latency of the SSD. And again, not the penalty of the not so great throughput given by the limit for large consecutive writes. There is, of course, a problem. Let us suppose you have your nice RAID 5 array for safety, no single point of failure, and you do the write back with a single SSD, and your SSD goes the way of all material things, and then some of your data is lost. So there are a few other details you have to consider. Even your SSD is not infinitely fast. It may be overloaded. In that case, there is a workaround so that Bcache just gives up after a few milliseconds, configurable, and writes to disk. So, and error handling is done by just bypassing the cache in the read case. That will not always work in the write-back mode because you may have dirty data that is only on the SSD. But then, well, benefits have costs. So, I've made benchmarks, so you are seeing actual numbers here. They have been done on this system. This is quite nice, a laptop, in my opinion. I like them large because it can accommodate multiple disks. So I've tested the worst case for Bcache against a RAID array. The worst case because for some operations, the read array actually doubles performance. Reads and writes of large masses of data, which can use both disks simultaneously, should, in theory, double the throughput. In practice, the doubling does not quite happen, but still, 2 disks, if you add up the throughput numbers, should be faster than one SSD, one cheap SSD. This was intentionally done to see the worst case. So, to the numbers, I used them as a RAID 0 array with 2 identical disks of 320 gigabytes. They are 5,400 RPMs SATA. And I've done the test against either them as a RAID 0 or one of the disks, or for comparison purposes against a file system on a conventional partition on the SSD. The tests were done with home. Oh, well, yes. Anything I forgot? No. Yes, it's, I remember. It is 32 gigabytes, and I used about 20 for them for cache. But all tests were done so that the test files are smaller than the cache size, so it should all fit in. I also limited the memory used in for the kernel to 1 gigabyte. So the test file sizes were between the memory size and the cache size. So the cache should be fully utilizable, but the memory should not really make the test meaningless. I allowed some significant memory so that you see the realistic effect of memory, which you would also see in normal testing. I ran this on factory state of a few weeks ago. In the beginning, I started out with a few practical tests, kernel compilation, I'm a kernel hacker, and doing a few grabs on my kernel sources. But then for systematic testing, I resorted to IO zone. IO zone because it in some ways represents a relatively hard case for Bcache. And I'm of the opinion that if you test something, you test it hard. I'd rather be positively surprised than negatively. iOzone does a lot of tests. Too many to really, well, no, frankly, the time didn't suffice for running them all. iOzone does take a lot of time. I use the tests for consecutive writes and rewrites on the theory that that should stress Bcache and I should see any negative performance impact. And I did do a random read and write to show more or less the best case for Bcache. I varied the record size used and the caching mode to see the influence of that, to get some significant data. Okay, now to a few selected results, those that are most significant. The other results I left out are somehow in the middle and not really interesting between the extreme cases I'm going to present here. Okay, this was the most basic case, the single disk with 128K record size. Blue is the write. Well, now you can read yourself. Now, the interesting fact here is that on the large data writes, Bcache just does not help. That was to be expected because there is the limit for large sequential writes, so it shouldn't be used at all. But it turns out that even switching this off does not make a significant difference. We're just seeing here that at sequential reads, and well, for reads we don't see it, but we could assume it. So at least for sequential writes, an SSD plus the administrative overhead just isn't that fast. So if you are nice and get me a faster SSD, I could rerun the tests, but I believe this to be the case from quite a lot of hardware. What we see here, that is in the write-back case, Bcache performs practically as good as the naked SSD, which is cool. So for at least that use case, perfect. Can't be done better. There was the great, well, yes, it made me sad. The reading case just doesn't help. Your SSD is beyond all expectations, but Bcache doesn't do it. This can in part be explained by the peculiarities of iOzone. In that configuration, there is just a low chance that a sector is reread. I've tried to change this by using read ahead, but for any reasonable read ahead setting, there is no significant difference. Yes?
I don't understand why you compare yourself against the SSD. Why not against the rotational medium?
The rotational medium itself is here, switching off the read-write feature.
I have a hard time reading this graphic.
Yeah. Sorry. Should have tested this on a Beamer, but okay, just for understanding purposes. This is the naked disk. This is with write around, so you don't cache writes. This is write back, caching writes, and here for experimental purposes, switching off the detection of large consecutive writes, and here's the naked SSD. So you can see that for consecutive writes, the caching neither hurts nor helps. It does the same, unfortunately, is true for the random read case. It is not true for caching writes. For caching writes, we are as fast as the naked SSD, more or less. For reads, Bcache sucks. And here you can see that SSDs are not that good at writing. the performance drops here, and the Bcache actually detects that and goes to the rotational disk as it should. So it doesn't hurt, but it doesn't help either, as was to be expected. But it's better to have a realistic picture there.
So the gist is Bcache doesn't help.
No, it does help. It does help in the right case. Right. So you can't say it doesn't help, but you cannot say it helps every time. Didn't I just show that? Oh, yes, sorry. So, make it even harder for Bcache. Set it against the RAID array. Worst case. You see, the naked RAID array is even faster. And again, Bcache does what it should. It doesn't help things, and neither does it hurt. It would hurt without the detection for sequential writes. And, well, these are identical, obviously. Here we see that the same behavior is true for the read case, random read. In random read, a RAID array should increase performance, but not linearly. There is a 50-50 chance that on the next read you hit the same disk and then you're screwed again. In the random write case, again we find that Bcache helps even better than the naked SSD itself, which is cool. And this shows us that you really shouldn't switch off the sequential detection here. Nice experimental feature, but in practice, don't. I've varied the record size, and you can see that this helps the SSD. Its performance increases. And Bcache, if you switch off the sequential detection, yes, this is significant if you run the numbers, but the effect is very, very small. So just don't do it. And here we again find that for reading it does not help. For writing, the effect is, if you run the numbers, significant, but again, small. So we have to conclude, even for large writes, Bcache is not what you want. Okay, and here we have the case that really stressed the rotational disk. This is a record size of 16K against the RAID array. 16K is smaller than the stripe size on the RAID array. So you have the full effect of the negative scaling on the RAID array for random reads and writes. Still, if you write consecutively, the RAID array does great. The Bcache does not quite so well. This is significant if you run the numbers. But again, the effect is small. But here you see that caching can actually hurt. So beware. Here we will find that switching off the sequential detection does help at the expense of rewriting. So for some use cases, SSDs really are weird. I can't explain that, honestly. But where you can see an extreme effect here is in the write back. It still isn't as good as the naked SSD, but it is about 3 times as fast as not using the SSD. So, cool. I mean, you have here an operation that is inherently slow, but it can be made 3 times faster, and sometimes, well, your data may come in chunks of 16K, or some smaller size, or slightly larger, and it can't be helped. So there it does something. Well, as I said, sometimes the results of your SSD are strange and can't really be explained. I used ext4 in those tests. Maybe I should have mentioned that. There is, I actually must admit that I don't know whether ext4 in that particular kernel version we use on factory uses the trim command. That might explain some of the peculiarities of the SSD, because Bcache would swallow the trim command if the file system were to issue it to the Bcache device. I just don't know. What we can conclude is that Bcache always accelerates the random write case, but it rarely does accelerate the random read case, and in the large consecutive write case and presumably read case, it is useless. I've tried to find out where the problem is for the random read case and the random write case. In the consecutive case, it is clear what should happen and expected happens. In the read case, this is not so, and I found out that our problem is the cache hit rate. Even in the best case, we have a cache hit rate of just 30%. And if you combine that with the overhead from the lookup of the failed cases, Bcache doesn't help. In the worst cases, where the performance dropped a little bit, I found a cache hit rate of 7%, which is useless. This is unfortunately not just an artifact of I/O zone, because on grabbing, the same could be observed. The numbers are identical, so I left them out for being boring. When you compile your kernel, which is a CPU-bound operation in practice, more or less, I found that this machine can do a kernel compilation on a naked rotational disk in 18 minutes, and with Bcache and writeback, it does take 17 minutes, 35 seconds. I ran the tests quite a lot of time and even did the chi-square test, so the result is significant, but it is very small, about 3.5%. Well, so far so good. So, what do we conclude here? I would say that there are use cases for which Bcache really rocks. The obvious one would be a mail server. But in the general use case, you might expect small benefits, but nothing spectacular. On the other hand, if your machine comes with, say, a 64 gigabyte SSD, then your reasonably sized root partition would be what? 30 gigs? 40? No, 40, it's just too large. So you have some space left, and why not use it? What I found when actually doing this, when you set up the Bcache, please load your module. You will have the weird effect that the partitions are correctly created if you don't, but they are not associated with each other. And then you have to manually type the unique IDs, and that is not a nice thing to do. What I further found is that in factory, the setup is quite brittle. There is no kernel detection, as I mentioned. This is done by using block ID on all partitions on startup and just registering them with the Bcache module and let the kernel do the association, which does work. The problem here is that if block ID fails, you have a problem. Currently, systemd will then drop you into repair mode, and you can do it yourself by hand, and then continue the boot, but pretty this is not. As you saw on my tests, you can combine Bcache with RAID. Now you can. I had to fix it. And We discussed this internally and came to the conclusion that the sane operation mode is to cache the RAID device as such, and not the partitions of which the RAID device is made up. It's just a waste to do that. And yes, let's look a bit in theory at the RAID solution, because RAID arrays, RAID 5 that is, have, from the way they work, the principal problem with a random write. They have to do that, read at least 2 stripes to compute the parity data, and RAID 6 would have to read them all. So, from theory, we should conclude that Bcache should be the ideal solution to cache random writes on RAID 5 arrays if you use the write-back operation. Frankly, we have no laptop which is large enough to hold so many disks that I could build a RAID 5 array to test. So I would have to reserve a test machine. At some point I will probably do that. But there is a limit to the tests I could do. So this table summarizes more or less what I found in testing against the RAID array. So what should we do for the distro? At present, Bcache works in the kernel perfectly. The tools are there, but still a bit buggy. But there is no support at all by Just. This means you can obviously not install on a Bcache device, which is not that bad because it makes no sense anyway. You would, for your special purpose, create a special partition or cache home or whatever partition you use. But on migration, this will bite us. We will have a device which just doesn't understand, and that is not good. Furthermore, if you want to do any administration just as shrinking your cache or enlarging it, which in Bcache would be done by creating a larger partition and detaching the cache and then reassociating with the backing store, you have to do that by hand, which involves typing the unique IDs and so on. Not nice, but doable. We would like some administrative support here if we decide that Bcache is the way to go for in the future for caching. And caching itself, what? Oh well. Anyway, and caching itself is sensible. What else we would like to have is a conversion on the fly if you want to migrate to Bcache. There is such a utility called block available on the internet, and frankly I didn't dare, but it exists. What else we would like to do is a safety feature. Currently your data is in principle safe against power failure on the SSD if you use the write-back mode and shutdown. But this is not good because it means that you can't switch your SSD when the machine is off. And if you cache against the RAID array, you lose the redundancy of a RAID array, RAID 5 that is, or RAID 1. Ideally, we would flush the Bcache whenever we shut down the machine, so there needs to be something done in, unfortunately, no longer the init scripts, but in systemd. Well, okay. I'd like, if the time permits, and it probably does, do a demonstration here, but I think questions, if they should arise, are more important. So if you have questions, please ask now.
Oh, I would like to ask you if there is someone behind that Bcache project, if it is just your ideas and you are working there, or if there is a cooperation with other developers and other companies. So we will not develop something in SUSE on our own and maintain that, but we will cooperate with others.
Okay, this is a mistake. I am not doing the Bcache code in the kernel. I'm just thinking it's cool and maintaining the user space tools for SLE. There is external Bcache development, but the group doing it is not large.
Did you try some tests with larger files, maybe?
Well, please have a second mic on, just in case. I don't know if that makes sense.
Doesn't work. Okay, I probably have to switch it on. So
Now, just fine.
test. Screw it. Anyway, yes, I did one test with a larger file. It shows that it doesn't make a difference. I should have tried perhaps smaller files, but then there is the danger that RAM does too much caching, and I would have to limit the machine RAM size so much that I don't think the test is realistic anymore. Any more questions?
Now that you've mentioned that again, Linux caches VFS operations itself, right?
I would say it's a VM operation, but that is probably talking about terms here.
Right. So I'm maybe being very naive. Wouldn't it be smart to enhance this VFS cache to use an SSD as, well, bigger storage, maybe, or extended storage, whatever? So then you wouldn't need to fiddle with the setup and everything. You just tell it, well, there's your flash drive, use that, for more storage of your VFS operations, and eventually do your thing whenever you want to.
Yeah. First of all, it obviously means that you couldn't decide what you want to cache. Secondly, yes, you could use the SSD as a swap medium. And on the third hand, somebody would need to try, actually. But expectations are that it would essentially be equivalent to using your SSD as a swap partition. Yes. I mean, if it weren't so, the result would be extremely exciting, but all predictions would point to being it like a swap partition.
With this setup, can we use Bcache on top of LVM things, or? And what was
yes. I don't know. So for the public, can we use it on LVM? Yes. Did I test with ButterFS? No. All tests were done with ext4. Just to be conservative there. Now I need to wear the corporate hat. The default is ButterFS only for the root partition. And as I just mentioned, I don't think it's sensible to use Bcache for the root. No more? Okay, then let me switch and hope that... No, 12 minutes. Actually, I had to leave 5, so that makes 7. Let's try. That was stupid. I should have switched it on earlier. Oh, shit. So far for the stability of Bcache in factory. Actually, we have it fixed now, but this laptop has some fixes not yet merged, and we are missing some features. So let's hope it boots with the Bcache partition destroyed, which I did this morning. Actually, isn't quite easy to really wipe the Bcache off your machine without totally hosing the file system. Come on. If you take this as a comment about having a faster and more stable factory, I would say the answer has been given. Yes. So let me get this into mirror mode. Doesn't work. Cool. So, can everybody see? Everybody but I? Yeah. Okay. Then let's do line typing. Large enough? Probably not. Now? Good. First thing, whenever you mess with Bcache, is load the module. If you do that, now I'm on the safe side. Okay, first thing you do then is you get your sysfs files directory, which has the register file, which is the heart of setting up Bcache. And like any competent hacker, we will look at the man page first. There you can see we have options for creating a cache and creating a backing device. And what this documentation does not tell you is that you should do this simultaneously. Then the association will be done automatically. This is the second partition on the SSD. And this laptop really has 2 hard drives. So, fire. Here we are. And you can see there is a Bcache device. The long string of numbers and hex you see there is the unique identity of the Bcache device. And there we have it. Let's get really experimental. Okay, you get your wish. I hope I have those tools. Ah, sorry. I hope this wasn't transmitted. Oh no. this should be butterfs. He wants it, he'll get it. Yes. Okay. I said edit anyway. Would you please do what I'm telling you? Yes. This is also wrong now. Do you know whether butterfs will be able to live with these attributes here? Okay. No? Okay. Defaults. Okay. And here we are. And it works. Yay. So, I guess we are already over time. So, any more questions?
The mic for the public, right?
Actually, I think you are looking for some test or some report about the usage or what we can do for that, and just give numbers on real bare metal, because I don't think MSATA thing is the right thing to test.
That is a question of your use case. I mean, modern laptops often come pre-equipped with the MSATA drive, so there will be a demand to make use of it. Obviously, there are other use cases, but I don't think you can take this to mean that one or the other use case is invalid, therefore. If you have your bit fact honking RAID array, yeah, then probably you do want a better SSD. Yeah, but that's just orthogonal, so.
Do you know of any deployments of Bcache in production? Have you maybe stumbled upon some reports about it, or?
Bcache uses this, if you count that as production. But other than that, no, I don't. Facebook uses caching heavily, but they have their own solution. Maybe next year I'll have a look at Enhanced I/O. Okay, then let's finish and hope there won't be a next speaker here. Oh well.
Well, thank you.